In this recording, we're going to look at the answer to a very difficult question. How could we find the length of side B in this triangle? Why don't you look this triangle over and see what clues you have and what information you could use that you already know to find side B. Well, for one, you'd probably think, hey, it's a right triangle, so I could use the Pythagorean theorem, but I don't have two sides. Oh, I could use SOHCAHTOA, right? We could use SOHCAHTOA. However, calculate carefully. It's 80 degrees here. So we can't use SOHCAHTOA. It's only applicable for right triangles. We're stuck. We need law of sines. So we're going to learn the law of sines here. We're going to derive it. We're going to do two quick examples. Law of sines applies to any triangle, and it's useful for finding unknown sides and unknown angles. It doesn't have to be a right triangle. So let's derive it together. So on your piece of notebook paper, I'd like you to sketch out this triangle, triangle ABC, with altitude drawn in AD. What we know about triangle ABC is it's an oblique triangle. We're not sure that it's a right triangle. So what we can apply is our area of triangles formula. Okay? I'd like you to consider angle C, sides A and sides B, and I'd like you to write an area equation. Remember, you just learned the area of an oblique triangle, so I'm looking at the overall area of this triangle ABC, and the area equation would be 1/2 AB times the sine of C. Okay? Two sides, the included angle. We have that information. So I'm going to write down 1/2 AB sine C. However, that's not the only two sides and included angle. I could also have done BC and angle A in between. So I want you to write down what would be the area of the triangle, which is still the same area of the triangle, using those two sides and that angle. So hopefully you said it was 1/2 BC times the sine of A. Remember, it's any letters, it's just two sides and the included angle. Thirdly, now we're going to take side A, side C, and angle B. And again, write the area formula for the same triangle. Play the recording when you've got it. So hopefully you did 1/2 AC times the sine of angle B. Very nice. With this pretty complicated three-headed monster, we're going to be able to come up with the law of sines formula. Okay, see a lot of redundancy in there. Let's get some of that out of here. Okay, we're going to divide through by half, by A, by B, and by C. Okay, so I want you to do that on your paper and divide out everything that is a common factor in each fraction. Okay, so hopefully you divide it out. Half A and B, half B and C, half A and C. Now write down what remains, and what remains is the law of sines. Pretty cool, you just derived it. Sine of C over little c, sine of angle A over little a, sine of angle B over little b. That is the law of sines. Now it looks pretty complicated, but in fact, when we actually have the law of sines, we only going to ever use two of its parts. Okay, we'd never use three sides to an equation. We'd have like sine C over little c equals sine A over little a, or perhaps we'd have something like this. In other words, you're only going to use two of the parts depending on the information that you know and what you're trying to find. Let's do two examples. First example I'd like you to write down is the following. We have triangle ABC. We're given that side C is 12, angle A is 75 degrees, and angle B is 26 degrees. Again, it's an oblique triangle. We can't use SOHCAHTOA. We can't use the Pythagorean theorem. We're going to find the length of side A to the nearest hundredth. So right now what I want you to figure out is which version of the law of sines, in other words, which pairs of angles and sides are going to be useful for us to find what we want. Okay, we're trying to find side A. We have known angle A angle B and side C. It'd be really nice if we knew angle C to match up with side C, right? Well, we can figure that out, right? So do some subtracting from 180 and you get that angle C is 79 degrees. Now we've got it. We're going to match up angle C with side C, angle A with side A. So the law of sines version that you're going to use is sine of angle A over A equals sine of angle C over C. Go ahead and, if you're asking why wouldn't I use anything to do with angle B and side B, well, because we don't know B, nor are we trying to find it. Okay, so don't have anything to do with B. Go ahead and sub in the information you know. You know angle A, you know angle C, you know side C, and this is just going to be left as an unknown. Okay, so you've subbed in all the information you have. I guess before you proceed, I'd like you to do a little estimation. Look over angle A and make a prediction for how big you think it's going to be. In other words, if I got angle A to come out 14, would that make any sense? And hopefully you could see that, no, that couldn't be, because side C is across from a bigger angle than side A, so A has to be smaller than 12, but not tons smaller. It's not going to be like 5. It's going to be a little smaller than 12, so make sure we're getting an answer that seems reasonable. At this point, we just need to do a little algebra down here to solve for side A. You're going to multiply both sides by the LCD, the A and the 12. Of course, the 12 divides out on this side, the A divides out on that side. That leaves us on the left side with 12 sine 75 degrees is equal to A times the sine of 79 degrees. Now we're looking to get A by itself, so divide by sine of 79 degrees. Now A is all by itself. These divide out on the right side, excuse me. So this becomes a calculator problem. Be in degree mode, type in a fraction, 12 sine 75 degrees over sine 79 degrees, and play the recording when you've got your answer. Hopefully you get that A is equal to 11.81. And that's about what we said it would be. A little smaller than 12, but not too much smaller. Okay, in our last example, we're going to look at solving for an unknown angle using the law of sines. Okay, I'd like you to sketch out this picture and write down the given information and what it is that we're trying to solve for. We're trying to find angle x to the nearest degree. This picture is not necessarily drawn to scale. Okay. I'd like you to circle the stuff that we know and the stuff that we're trying to find, and see if you can narrow it down to a version of the law of sines involving x's and y's and z's. So hopefully you circled the following. Okay, we're trying to find x. Well, that matches up with the side across from it. And we know the value of angle y as well as side y. So that means we're going to use sine of x over little x equal to sine of angle y over little y. Go ahead and sub in all the values you know, and then we'll proceed to do the algebra to solve. Okay. Subbing in the information we know, we've got this pair of fractions. We've got to solve this proportion. So we solve a proportion by multiplying both sides by the LCD, 13 times 15. Divide out the 15s, divide out the 13s. We're left with 15 times the sine of x is equal to 13 times the sine of 94. Keep in mind, angle x is unknown. We're going to need to use inverse sine. Divide both sides by 15, and you've got this fraction. So that's pretty good. We've got the sine of x is equal to this expression. These are all numbers which you can put in our calculator. Okay. Now remember, to get x by itself, we have to do inverse sine. So I'm going to put this fraction in my calculator, in degree mode. Okay, so I've got it here. Now I'm going to do the inverse sine of this answer. So just cursor up on top or hit ans. It comes out to be 60 degrees. Now I have to consider if that's a reasonable answer. It's a smaller angle than 94, and 13 is a smaller side than 15. Thanks for watching.